Good afternoon, everybody. I'm Dr. Nicola Knight. I am the coordinator of the Physical Sciences Data Infrastructure, and we are running our the latest in our webinar series today. So today we have a guest speaker coming to talk to us from the FAIRmat project. So I'm just going to give a little introduction to the webinar itself and then to our speaker before handing over. So Hampus Nystrom is our speaker today, and he got his PhD at Humboldt University of Berlin. Working on combinatorial synthesis of solar cell materials with a focus on high throughput experimentation and lab automation. With his domain knowledge in material synthesis and the technical expertise in large data management and analysis pipelines, he started working at the FAIRmat project on developing the research data management tool NOMAD. And today he will be presenting about the NOMAD ecosystem and showcasing its applications in material synthesis, characterization, simulations, and AI-driven research. So without further ado, I'll hand over to you, Hampus.
Thank you. Thank you so much. And thank you everyone for coming. So let's see. Yeah, here I see all the attendees. Nice. Yeah, so that was an excellent introduction. I don't think I need to say so much more. So basically, like I said, I will talk about a little bit about NOMAD today. I'll tell you guys about this. But just before we get into this and before I start, I just want to say that all the slides, so from this talk with all the links and everything, will be published to our FAIRmat Zenodo community. So zenodo.org/communities FAIRmat NFDI, or you just go to Zenodo and search for FAIRmat NFDI. After the talk, I'll just upload them there. So there's no need to panic with screenshots and things like this if there's something that you find interesting. So then you can just go and find that afterwards. Okay, so with that out of the way, I'll just go through a little bit what I want to tell you about today. So the first thing I want to talk a little bit about, what is FAIRmat, because maybe you came here, you saw the title with NOMAD, but I'll talk a little bit about what FAIRmat is, and then I'll get into NOMAD itself. And then I'll talk about some of these examples that we have with people actually using NOMAD, and some of the example use cases that we can see. And then we'll go in a little bit into detail about our tool NOMAD Oasis and the plugin system that we have. And I'll explain all of this, of course, in detail later. Then finally, I was asked by Sammy actually to focus a little bit on like how would you actually get started in NOMAD. So all of these things will showcase some of the things you can do in NOMAD, but here at the end I want to focus a little bit on like hands-on, like how would you actually get started on the different levels that you are. And then I hope to leave a lot of time so that we can have some questions and answers, because I think this is really how we learn something from all of this. And if you have something urgent during the talk that you don't really understand or so, just drop it in the chat. I'll try to keep a look at it. And if I miss something, then we'll try to go through it all in the end. Okay, but without further ado, let's get started. So as promised, what is FAIRmat? So FAIRmat is an NFDI consortium. So NFDI is the National German Research Data Infrastructure Project. And we are a consortium in this NFDI, and we aim to build a fair federated data infrastructure for solid state physics. So we do these in a couple of different areas. So within solid state physics, we're working within synthesis, within experiments or measurements, within computation. And then we have a bunch of use cases where we are trying to apply these things together. And then in addition to these things, we need to have some infrastructure to support all of this. We have an area for training and outreach. And then we, of course, need to coordinate the whole projects. These are these sectors of the wheel here on the left. And the core principles that we work from are the FAIR principles. And I think in a seminar like this, I don't need to reiterate what FAIR means. So in all the things we do, we really stand behind that we want to create fair data and work in a fair way. The second thing is that everything we do is open source. So we publish everything on either our GitLab page or our GitHub page, and all the code we develop is open source. All the documents we produce, everything like this is uploaded to Zenodo. So everything should be available. And we really strive towards open science. So we strive towards our users doing the same. That being said, there are still ways that you can use NOMAD without directly like opening everything up. But in our core values are that we really want to support this open science. And finally, we want to work in a bottom-up approach. So we don't want to impose a lot of structures and guidelines from the top on what users need to do, but rather we want to work with users. So primarily in Germany to begin with, but now I'm actually working with people from all over Europe and actually all over the world to define things together. What are the things that we need in order to build this federated data structure for solid state physics together? So in FAIRmat, we work a little bit different from a lot of other of these NFDI consortia in Germany. And we work in that we have 60 PIs, which are spread out over Germany. But in addition to that, we have 30 central co-workers that all work in one building in Berlin. In that sense, we work more as a small startup than as maybe a classic NFDI consortium or a classic research project, where we are working together with this goal of building the tool. And what is this tool then? The tool is the NOMAD ecosystem. And the NOMAD ecosystem is split up into a few different parts, with the main part being NOMAD, but we're now extending it also with NOMAD Oasis and later also NOMAD CAMELS, which I'll tell you more about. So, but first about NOMAD. So NOMAD is the main product that we develop at FAIRmat, and it's a web-based software where you can do research data management for material sciences. So the idea here is that you can upload files, process these files, and we try to extract structured metadata from this. And then you can explore this data and reuse data from different sources and find everything through a unified interface. And at the moment of this recording, or I think we are even above this, because I think these slides were prepared last week, we have about 16.5 million uploaded entries, around 110 terabytes of data, and over 4,000 registered users on this NOMAD Lab website. And this is sort of the classic NOMAD, which has been around for a long time. But what we are doing now as well is that we are introducing NOMAD Oasis, which is a local management tool, which is basically taking the central NOMAD and installing it locally at your universities. And there you can then adapt to whatever your data management practices are, your lab policies. You can create custom tools for this. And I think we have about over 60 registered installations all over Germany, but also in Illinois, in the US. We have the DTU in Copenhagen. So it's spread out. It's not just in Germany. And then the third tool that we are working on and developing is the NOMAD CAMELS. So NOMAD CAMELS is a control software. So that's taking this whole idea of a fair data structure all the way back to when you're actually collecting the data. So it's a way of creating a measurement setup locally and record directly fair data that can be directly ingested into NOMAD. And all of this together gives FAIRmat this federated data infrastructure where we have a central NOMAD hub, and then the different institutes, different universities and so on can apply this NOMAD Oasis, so they can have this NOMAD Oasis running locally, maybe with the NOMAD CAMELS measurement systems and so on, where they federate or where they control their data acquisition, they store their data and so on, and then this can later on be transferred between the Oases, but also up to the NOMAD Oasis. Sorry, to the central NOMAD installation. So what can you do in NOMAD? So the core functionalities of the central NOMAD is that you can query your repository. So you can go to this repository and you can query it by elements, materials, methods, and you can find different materials that have been calculated or even now also created experimentally. So when you go to the main NOMAD Explore view, you get greeted by a bunch of different filters. So here we have the element filters where we can filter on different materials. So we've selected some materials here and apply these filters. And if you do this, then you get a list of these different entries that fulfill these criteria. And you can filter by a lot of different things here. You can go through later and have a look yourself at what all the different things you can do. And once you filtered and found what you're interested in, you can access this data. And on the first view that you get from this data, you get an essential overview of the data. So you see what is this material about here, you get an idea of the structure of this material, and if we scroll down, you might see some information that has been extracted from the code in this case that run. So in this case, it's electronic properties that have been stated in here. And then behind all of this data, we have this structured data that we are building NOMAD on. And we can browse this detailed structured data of each entry, and we have a standardized schema that this then builds on into. And if we do that, we can see here that we have this nested structure where all of this information that builds the overview, that builds the search, is stored inside each of these entries. And to get these entries into NOMAD, it works a little bit like just a Dropbox. So basically, you can just upload your research data into NOMAD, into what we call an upload. And then you can share them with collaborators, you can publish them, and you get DOIs, basically. And if NOMAD recognizes the things that you are uploading, then we also extract a lot of this standardized metadata that we can then use to compare with other entries. So basically, you can take your files that you have. In this case, it's a zip file here with some outputs from some calculation code. And you can just upload that into NOMAD. So you just drag and drop that file into this NOMAD upload, and then NOMAD will process this data. And you can see that it has extracted 3 entries in this case. And it will try to extract all the meta info out of this data. And you can go and edit this upload. So you can edit, for example, what members are in the upload. So here we can add some, maybe have a co-author. So we'll say that Siakmak is a co-author here of this. We can add him and select the role of co-author or reviewer. And this will then apply to all the data that is in this upload. And then later on, we can go down and publish this data, and then we can set an embargo period so that if we want to have a certain embargo period before it actually becomes public, we can do that down there. And if we go ahead, we saw that the 3 of these entries were registered in NOMAD, so we can go and have a look at these. So if we click one of these entries here that was uploaded, we see again this material overview page that from before, where we get this interactive view of where we can look at how the NOMAD has interpreted our data, basically. And again, in this case here, the electronic properties, we also see the Brion zones and so on. And we also get some generalized abstraction of our data, in this case, in terms of a workflow diagram, where we get ideas about this. And if we click these individual nodes, we get taken again back to the structured data that builds up NOMAD, that gives NOMAD this power of generalization and about building these tools where we can explore it. So speaking of that, the structured data. So NOMAD itself is built on a custom data schema. So we have something called NOMAD meta info, which is what you use to model the data and model the schemas in NOMAD. But NOMAD can also be enhanced, so we can understand and export into Nexus format as well. We can annotate with things like voc4cat, which we do for the catalysis. We also expose our data through different APIs. So for example, the Optimate API, so that you can access the data in different ways. And we are working on adapting to more and more of these tools. So this is sort of the core functionality of NOMAD, what you can do with NOMAD. And now I thought I would just show some examples of where NOMAD has been applied. So on the first thing we have here, we have the search apps. So if you go to NOMAD and you go to explore, you can see the general one, which I showed you before, but we also have some use cases here. I don't know how big this is if people see, but we basically have the solar cells use case. We have one for metal organic frameworks, and we have one for heterogeneous catalysis. And these you can just explore on the NOMAD Lab webpage. We have the solar cells, for example, where we have integrated more than 40,000 devices from a project called the Perovskite Database Project, so that we can explore those in NOMAD. We also have the Metal Organic Frameworks app, which is containing about 17,000 calculations, and now we are also trying to expand this to synthesis conditions. And then we have an app which has been developed on this heterogeneous catalysis, where we offer visualization, but also filtering based on synthesis conditions, so that you can filter out these catalysis on a very domain-specific side. And so, for example, for this solar cell example, if you go to the solar cell app, you get greeted with a similar page to what I showed you before, where you saw the periodic table, but now we also have some specialized fields underneath here. So in this case, we have a scatter plot here where we see the efficiency as a function of the open circuit voltage for these solar cells. And a lot of these solar cells are taken from this Perovskite database project, which was a project that I was actually involved in during my PhD, where we extracted data from a lot of literature, because in the Perovskite field, there's, I think, about 100 papers published in a week or something like this. So there is no way to actually manually go through these, all of these, like for the researchers. So we basically conquered and divided. We did split this up into, so every researcher's got a bunch of papers, and then we manually extracted a lot of this data. And actually now we're working on extending this to work on some sort of LLM to extract more of this information. But this is what let us build up this database in NOMAD with over 40,000 entries. And now we can do interactive filtering here in NOMAD. So if we say, for example, that we are looking for solar cells that contain tin, then you see that all of the graphics update almost instantaneously because of the structured data that we have behind NOMAD. And we can imagine that we are a student that is going to make a solar cell out of tin, and they are maybe using C60 as their contact layer, and then they want to try to figure out, okay, so what is a good whole transport layer to combine with this? So then you can try to select and customize this plot so that you can see here the different efficiencies for different types of whole contact layers here that people have tried on top. So this is one use case of NOMAD. And of course, this is just for filtering here on the top. And then again, this table here at the bottom gets updated so that you can go and look at the details of these. You also have a reference to the actual publication where this was done and so on. This is just one of the use cases that we see for NOMAD, and there are plenty more of people working around and doing these sort of things. So like I hinted to before with this NOMAD and the NOMAD Oasis, so NOMAD comes in two flavors, right? We have this central NOMAD, which is sort of like an archive repository where you can just drop your data, you publish it, there is some extraction run on it, and then you can run some analysis on this data. But it has limited flexibility, right? So you can only use the predefined schemas which exist on the central NOMAD, and there are some ways to create custom schemas, but you are less flexible here, right? And on the same time, we have developed this NOMAD Oasis, which is basically a local copy of the central NOMAD tool, but meant to run in your lab. So that you can use it to create electronic lab notebooks, you can add automation and things like this. So I want to talk a little bit about this NOMAD Oasis and what you can do with NOMAD Oasis. So the first thing, which I think is the key use case that people use this NOMAD Oasis for, is that they set up an ELN, right? So you can set up these electronic lab notebooks, and that's not something special per se. There's lots of electronic lab notebooks out there. But what we really believe in NOMAD is that in addition to having some general field where you can put text, NOMAD is really built on this structured data, right? So we let people define structured electronic lab notebooks where people can input their data and where NOMAD understands their data. So here is some data, for example, where we can change the units, and since NOMAD understands what this data is, we can actually change this data, we can visualize this data, we can search by this data, and so on. And in addition to this electronic lab notebook understanding the data, we can automate things in this notebook, right? So we can add some automated data extraction. So that, for example, in this solar cell use case here, we can upload an EQE file, so an external quantum efficiency measurement. And when we upload this file, NOMAD can then extract out the data that's in this file, and it can also run some standardized analysis. So in this case, we are calculating out the Urbach energy of the photoabsorber in the solar cell. And we do this in the same way for all the solar cells that are uploaded so that we get comparable data that we can then view and compare. And this is being used actually in a lot of different labs. So this solar cell schema is used in plenty of different institutes all over Germany. And in addition to this, we have the capability of handling large files or measurement files directly. So we have support for Nexus in NOMAD. So Nexus is a standard for a measurement system that started in the neutron and X-ray field, but is now being expanded also as part of the FAIRmat initiative into other fields. And NOMAD supports this on the fly, so that if you upload a Nexus file into NOMAD, NOMAD automatically understands what is in this, and you can get interactive plots of these large data files where you can view here, for example, the photo emission measurement that we have here interactively. Although these can be very, very large files, but since you can store them locally in your Oasis, you can still view them through NOMAD. In addition to this, we also have something called North, which is the NOMAD Remote Tools Hub. And in the NOMAD Remote Tools Hub, you can run remote tools, right? So you can run things like a Jupyter Hub, for example, where you will have direct access to the files. So the users can write their Julia scripts, their Python scripts, their R scripts, what they want to do, with direct access to all of the data that you have uploaded. But it's being run in the NOMAD Oasis instead of on the people's individual computers, which have a couple of advantages. One is that you have direct access to the data that's on the server. You don't need to download data from a server, from a measurement server or so before running analysis. It's also centralizing compute resources. So you can use the compute resources of the server. And it also makes the analysis more fair because we are starting to develop schemas for actually recognizing these Jupyter notebooks and understanding what is happening in them, so that the analysis itself can also be stored as part of the record, and that when you create a publication of this dataset later, the actual analysis is part of this and shipped with it. It also integrates with NOMAD and so on. But it's not just Jupyter. We have also a lot of other tools. So something like Fiji and PyIron. And you can also extend this. So basically any tool that can run in a web Docker container, you could add to North and mount it and have direct access to the file. So there are, for example, people who use Igor Pro, and they have created a North container where they put Igor Pro, and then they can use this in their Oasis. So it can be very, very powerful. And here we see an example of how this North tool looks. You have these different tools here, and then you can just launch them, and they launch inside of the web interface, and you have direct access to the things that you need. Another thing that you can customize in your NOMAD Oasis are these search apps that I was showing you before, right? With the solar cell one, for example. So here you can create customized visualizations of the things that you are working on. So this is actually from an example that we ran during the user meeting. So this is available as an upload that you can also try yourself later if you want. Where you can then create these custom search app based on what it is that you're doing, what the science is that you are doing, what do you need to see, and so on. You could also create inventories and things like this here in the search app, so that you can have an overview of what are the processes that have been done on certain objects or certain items in the lab. And all of this customization is done in NOMAD through something called plugins. So we have these NOMAD plugins, which are basically add-ons onto what we have in the central NOMAD. So we can take these add-ons and plug them into NOMAD, and this gives us some modularity. We can update in a much easier way, and we can also collaborate on these plugins, right? So these plugins can then be published, and they can be used in other Oases, so that other people can make use of what you have done, the new readers that you have written for files, or parsers for files, or the new visualizations that you have developed. So there's a bunch of different ones that you can work on. So you can work on schema packages. These are defining these fields, these schemas that we use in NOMAD. You can also define these parsers, so readers and things like this. So basically for any file that you have on your local lab that you want to upload to NOMAD, you can write these parsers and so on. And then you can write these apps, which are these search visualizations that I was talking about before, where you can have different views of the data and create these things. And all of these can then be deployed onto your NOMAD Oasis so that you can customize it to what it is that you need. And there are some of these NOMAD plugins that are also developed by FAIRmat. So we have, for example, the NOMAD Material Processing plugin, NOMAD Measurements plugin, and so on. And these plugins are available. You can find them on our GitHub. I'll provide some links later. And these can then be added directly into your existing Oasis, and you can customize this then. So if you say that I don't need these things, then you can deactivate these things, and then you can customize to your will, basically, what is it that you need in your local lab to get it up and running. And like I said, you can write your own plugins, and one plugin package can contain everything. So you can just create one plugin that contains a lot of different things. So it can be schemas, parsers, apps, all of it together. And then you can just activate and deactivate this, and you can have different plugins written maybe for different groups that are running on the same Oasis and so on. and you activate them through something called entry points. And there are template repositories for how to set this up, so there's nothing that you need to, it shouldn't be too technical to set this up. But with that being said, I thought I would go as a last bit here into a little bit on how do you actually do this? How do you actually get started with Nomad, right? So now we say, okay, so Nomad is great. We want to use it, but how do you actually get started, and how do we actually jump in to use this? And I think one thing that you should first think about is to identify a little bit your role, because Nomad is a very, very flexible tool. It's a very powerful tool, but it can also get a little bit overwhelming if you don't really, if you're not clear on where you put your level, so to say. So if you are just a user that wants to use Nomad, you want to upload the datasets, search datasets, use predefined applications and so on, then you should aim at this level, so to say. And this is available in the central Nomad. Of course, you can do this in the NOMAD Oasis and so on, but to set this up, the Nomad plugins and the NOMAD Oasis, you might need help from other users, right? So the second level here is something like an application administrator. So here we are talking about someone who has a little bit more experience, maybe with writing Python code to set up these things, because to write these Nomad plugins, you have to develop these, you have to write these, and the programming language we're using is Python. And it does take a little bit more experience, right? So if you feel that you're not on that level, then that's perfectly fine. Nomad is perfectly usable, either centrally, or if you can get help from someone to set this up, then you can do your day-to-day business without having to touch any of these things, right? And if you're on this level, then you can implement and create these use-based applications, so you can write your schemas, your parsers, and so on, your different plugins, so that other users can use these. And of course, there's no clear-cut, black and white here in between these things bleed together. And then on the bottom level, we have something like a system administrator, right? That sets up this NOMAD Oasis. And then you have to have now a little bit more knowledge about, how do Docker containers run on a Linux server, and how do you deploy these and so on. It's not super complicated, and it's something that you can definitely figure out. But if you want to run this on a server at your institute, then I would highly recommend to contact someone in your IT, and they definitely know these things, right? And we have clear instructions for how to do this, and we set this up so in such a way that the IT people don't need to know about the details of these things. They can just maintain this whilst these guys can configure and decide, oh, what sort of plugins do we want to run? What sort of things do we need to happen on our Oasis? So with that, I thought I would just iterate a little bit what you can do on these different levels. So if we start here on the central Nomad, so using the central installation, a little bit in the order of sort of complexity. The first thing that you can just do if you want to start using Nomad today is that you can go to the Explore view, like I showed you before. So you just head to nomadlab.eu and you click Open Nomad. And then directly you can start to use Nomad, in the sense that without even logging in, you can view data, you can explore what people have done in your field, you can search for different data and so on. So that's sort of the very, very easiest first level that anyone should be able to do. The second thing you can do is that you can use the built-in parsers. So if you have some calculation in one of these 60+ DFT codes that we support, or if you have Nexus files from a measurement or something like this, then you can just drop your files in Nomad, right? It's a matter of just creating an account, which is very quickly, and then you just drag and drop the file. So that's something that you can just start with today, very, very straightforward. And with that, you can also publish data, right? So once you have uploaded data, it's just a click away from actually publishing this data. So you can upload any additional files that you want in there. Nomad is basically like a zenodo box, right? You can put any data in there, even if Nomad doesn't necessarily recognize it. You can set the embargo period, like I showed you before, and you will get the DOI. And then you can just publish these things, right? And this is explained if you need some more instructions on exactly where to click and how to do this and so on. There's the first tutorial that we did is actually exactly on this. So Marcus Scheitgen, our lead developer, is explaining this there's a YouTube video where he is going through all of this, and I'll give you some links later on for where you can find these tutorials and so on. And if you want to go a little bit beyond this, so if you want to stop here, that's perfectly fine. But if you want to get a little bit more use out of the central Nomad, you can use the built-in ELNs. So if you say that you have some data that you want to share, you want to take some notes, you can use some of these built-in ELAN classes. So we don't get this full advantage of the structured data in NOMAD, but we get some of it, right? So we have thought about some general ELAN classes that you can use, where you can jot down your ideas, and importantly, you can at least link the data together, right? So you get this concept of having samples which get linked to measurements and so on, even if the details of maybe the measurements in the sample are not as detailed maybe as they are in the case of these built-in parsers and so on. And tutorial 13, the beginning of tutorial 13 talks a lot about this. So my colleague shows exactly how to click and where to do to use these built-in ELNs. And if you want to move beyond this, so if you want to say, I want to provide a little bit more information about my measurements, for example, and I want to have the structured fields that you showed me before, Hampus, these drop-down menus where it understands the units and so on, then you can write custom schemas and parser, actually also in the central NOMAD. So you can do this using some YAML or JSON notation, where you basically write, okay, I want to have this quantities, and this should have this unit, and so on and so forth. And it's not too difficult. And then you can upload that into your upload, and that gives you then the possibility to use these custom ELNs. And you can also reuse existing functionality. So if we have some of these classes that we have developed, then you can reuse those in here and so on. And there are also some general parsers that you can use. So there is a general tabular parser for example, parsing in Excel data, which is a very, very common use case, right? So that you can write your schema and map in Excel columns to match certain things. And you can start to build up some automation even in the central NOMAD. And then there is a new tool, which is unfortunately not so well documented right now, but I'm sure this will come soon, which is just a JSON mapper, which basically lets you take data from some other database that you want to put in NOMAD, and you just tell, this field should go here, this field should go here, and so on. It starts to get a little bit more complex, but it's definitely a powerful tool. And in tutorial 8, we talk a lot about this, right? So if you want some more information about this, then tutorial 8 is the place to go, where we talk a lot about how you write your schemas, how do you use this tabular parser, and so on. And then you can, of course, run the analysis in North, like I showed you before, right? So like I mentioned, you get direct file access, you get the use of this Jupyter Notebook, Fiji, and so on. So just now, you just create an account on NOMAD, you go, you drop some files in an upload, and then you can directly use this Jupyter Notebook in the central NOMAD and run some analysis on them and publish this, right? So you could run your analysis, make some plots and so on, and publish it, get a DOI, and say, here's how I did this analysis of this data set, right? And there are some example images. Of course, you might not be able to find the exact tool that you use locally on the central NOMAD, but there are quite a few there that you can use. And I think the last important way how you can use NOMAD is through our APIs. So this application programming interface, right? Where you can query any of the data that's in NOMAD, right? And NOMAD actually has, in a lot of places, it has this little button where you can find out how was this page that I'm seeing in NOMAD now created, and you can see the query, and then that gives you an idea of how you can actually do this. And in addition to our main API, which is what is used by the GUI and so on, we also support the Optimate API. This is specifically for materials, for calculated materials, so that you can use the Optimate endpoints. And we also have very limited support for also a DCAT, where you can just get a very general overview of our entries, basically. So that's things that you can get started with already now in the central NOMAD without any further problems, right? Just make an account and start, and even this Explore view you can do without an account. If you want to go a little bit above that, and you say, I have some experience writing a little bit of Python code, I want to write my custom schemas, and I want to use some little more specialized tools, then you can move on to the NOMAD plugin system, right? And here you will need an Oasis, which is the last step that I will go through, what you can do in terms of setting up an Oasis. So either you try to do this yourself, or you ask someone to set up an Oasis. But once you have an Oasis, then you can do a lot with this plugin system without knowing much about the Oasis, right? So one thing you can do is that you can set it up to use existing plugins. So these plugins that I mentioned that we develop in FAIRmat. So they are available on our GitHub page, github.com/FAIRmat NFDI. And there you can find all the plugins that we develop. Also find these templates and so on. And we also have a test oasis where you can test some of these out, right? So this test oasis is not the stable one, so we change things there from time to time. But it's an excellent place to start already now getting a feel for, okay, so how do these different plugins work? Because most of them are running there on this test oasis. And then of course you want to develop your own plugins, right? So that's the thing. And here we have an excellent tutorial in the docs that goes through exactly the steps for how do you set up your GitHub repository for starting developing your plugins. What are the first steps that you need to do? What are the different types of plugins that you can develop and so on? And that's something that you can start with from there. So I would go through to the NOMAD docs again. I'll show you some links later. You can start from there, and you can do this. There's also an example upload that you can access through NOMAD. So in your upload page from NOMAD, you can create an example upload. And there, Lauri has prepared a really nice instruction for how do you write these things in Python, these codes and so on. And like I said, there's a cookie cutter template, so you don't have to worry so much about all of the setting up the GitHub repository for this code and everything like that. That should be taken care of. And all you need to worry about is writing the Python code that maybe calculates the Urbach energy from your external quantum efficiency or whatever it is that you want to do. So what is it that you can do? The first thing that you can do is just write schemas, right? And a little bit more than these YAML and JSON schemas that I talked to you before about in the central Nomad. Here you can then add automation, right? So you can add this reading that I showed you of the EQE. You can create custom plots so that when you go to the overview, we saw this interactive view of the molecule. Maybe you're not working on a molecular level, you're working on solar cells. Then maybe you want to create a plot which shows the layers in the solar cell, and you want to show your JV curve, for example, of the solar cell. Then you can add that in this custom plot view here. And then you can write your own parsers. So like we saw in NOMAD, you can drag and drop files, and if NOMAD recognizes them, then we do something with them. And this is here what you can do. You can extend what we recognize, right? So you can read any sort of files that you want. You can match by different things, so the type of the file, the name of it, or even the content that's inside of it. And then you can decide, oh, this is a file of this type, and then you write a reader which can do this. And you can also add linking then to other entries so that you get this connected data set. And then finally, you can create visualizations of all of this. So once you have some custom schemas and some custom parsers, and you want to create a custom visualization, you can create these dashboards where you can get an overview of your data with custom search fields and so on, custom visualizations, and also things like an inventory app, right? And this is usually very, very appreciated by group leaders, right? Because users or individual PhD students or postdocs, they work a lot on this level here. And then on this level, it's very easy to get an overview. You can basically see, okay, what are the different things that are working in the group now, what's happening, and you can create these interactive dashboards. So that's on the NOMAD plugin level. And then, like I said, to do this, you need to have your own Oasis. And how would you then? What are the steps now? If you want to get started and host your own installation of NOMAD Oasis, how do you go about this? So the first thing that you could do if you just want to host a NOMAD Oasis, you have a server lying around or even just a powerful computer, is that you can just run the default NOMAD. So basically, you just run exactly the same thing that we run on our central NOMAD, and you just start that up. So that's basically as simple as Docker compose pull, Docker compose up, if you know Docker. That's it, and then you can run Docker. If you, for some reason, don't want to run Docker, there are also instructions for how to run this on base Linux, right? So if you just want to set it up completely from scratch, you can also do this, although the Docker image is by far the easiest way to do this. But this is, of course, a limited use, right? So the reason that you want to run your NOMAD Oasis is that you want to customize it. And the way you do this is that you, instead of building or using the default Docker NOMAD image, you build a custom image. Okay, and now sorry, before I go any further, if all of this sounds like gibberish to you, then maybe that's because of these different user levels, right? So just bear with me for a second. I will get back to some links and some interesting stuff in a second, right? But if you are really into hosting your NOMAD Oasis, and you maybe already know what a Docker is, then you can create these custom Docker images. And we have a template repository for doing this, which is set up with GitHub Actions already, so that the people who are on sort of this mid-level that I talked about before in the users, they can actually configure the Oasis so that you as an IT person maybe don't need to worry so much about solar cells and all these things that you have no idea about, but you let the users configure what plugins they need. They do this with sort of easy configuration files. And then this GitHub action builds this custom image for you, and you can just pull this image and update it. And then when the users say, oh, I did some changes to my plugin, can you please pull it? And you just do, Docker compose pull, Docker compose up, and that's it. And we have more docs coming on this. So if you watch this video later, you should find some docs also in the NOMAD docs. For now, tutorial 13 is the best place to go. So the end of tutorial 13, we talk a lot about how this template repository work. But there are also instructions in the README of the repository itself. So that should get you quite far. And in addition to working with these custom images, if we go up a little bit in the complexity scale here, you could in principle also create your custom north images, right? Here we have users who, for example, they use Igor Pro, which is a proprietary analysis software, and they've created a north image so that they can run this with directly the files that they have on their computer. There's also one for Casa XPS and so on, and people have done this to create voila dashboards, for example. So there's a lot of things that you can do here to create these north images if you have some special software that your users need, basically. And tied into this, that you can work with your local file system, right? So if you have already file shares running on your servers where the users have heavy files, say they're talking about TEM or something like this, right? Where you're talking about terabytes of data, you don't really want to set this up where you move this to the server. So instead, you can then work with the local file system so that you mount these existing drives in, and this then supports working with these very large files. And then finally, you can also customize the user management, right? So on an easy level, you can configure user groups. This is actually not so high on the complexity levels, probably further down here. But you can also set up to use internal key cloaks and things like this, so that you're not tied to using the NOMAD one. So that's things that, on the different levels, what you could get started with right now if you want to start using NOMAD. That being said, I referenced to a lot of things here, right? Tutorial 13, tutorial 12, and so on. So where can you find all of this information? So our main website is the nomadlab.eu for NOMAD. And here under Learn, you find our documentation, for example. Here is where you open NOMAD. So if you just click Open NOMAD here, you get to the Explore view that I talked to you before. But if you click on this documentation view here, then you get taken to the NOMAD documentation. And here you find some tutorials which are written, some written tutorials. So these are not the numbered ones, those are FAIRmat tutorials, confusingly enough. But here is written tutorials. So here, for example, if you open this, you can find things like this, how to publish a plugin and things like this. Then we also have the FAIRmat webpage, which is the FAIRmat.nfdi.eu. And here, under Outreach FAIRmat Tutorials FAIRmat, then you can find these different tutorials that we have. So when I said numbered tutorials, like you can look at tutorial 1 or you can look at tutorial 8, you find all of these tutorials here. And a lot of these tutorials also have accompanied YouTube videos that you find on our YouTube channel, the NOMAD Laboratory, where we publish talks, and also all of our tutorials that we do are on there, so that you can have a look at them. And then the best for last, we also have a Discord community, and this is really great. So we started this in the beginning of the year, and I can highly recommend that if you want to start with NOMAD, really join the Discord community. I think we have over 400 members now, and it's not just us, the people at FAIRmat developing NOMAD that answer questions, but also different users can help you out. So the users help each other out, and it's really a great place if you want to have any support on something, it's not working, you cannot find it in the docs or whatever it could be. You can just write there on the NOMAD Discord, and then there's someone will be there to help you. Yeah, so that brings me close to the end. So I just want to give some shout out that this year or next year, sorry, in 2025, FAIRmat will be at some events. So we'll be maybe not so so important for the people in the UK. We'll be at but it's in Germany. It's a big thing, right? The DPG will be there. EMRS, I'm guessing that maybe some people from the PSDI could be there, and then also in the Psyche conference in Lausanne. And you can find more on this FAIRmat events page there. And with that, that brings me to the end. So like I said, there's information on FAIRmat NFDI on nomadlab.eu, and I will publish the slides from the talk to our zenodo, so that if you want to have more information, if you want to find these links that I was talking about, have a look at any of this, then this should be there soonish, maybe by the end of the week or latest beginning of next week. And with that, I'm happy to take some questions if we have any. There's none yet, but maybe.
I was going to say, thank you, Hampus, for a really, really interesting presentation all about Nomad. So yeah, I just encourage, oh, I can see somebody's just put one in. So yes, you can either ask some questions through the chat, we'll pick them up in there, or in the Q&A panel, and everybody should also be able to see kind of if you see other people's questions in there.
Okay, is NOMAD cooperating with publishers and funding bodies? I think if funders and publishers suggest NOMAD, it would push data in FAIR rather than some data swamp. Yeah, this is a very good point. So for the computational field, then NOMAD is one of these recognized repositories. So if you publish in, so I'm not from the computational field, so you have to bear with me, but when you publish calculations, DFT, and so on to these journals, they require you to publish the data in some repository, and NOMAD is one of these that are required. So in that sense, we do this, right, for the computational side. For the experimental side, it is a bit more of a struggle, right, because there is not this history, I think, of people necessarily uploading and sharing their data in this way. That being said, there are some pushes in, for example, the perovskite field that I was talking about, where people are encouraged to upload data and show certain measurements in certain ways, and NOMAD can definitely be used for that, even if there is no official link to sort of that you should use NOMAD. But I completely agree. I think this is really, we need to give people the way that they can publish the data, and that it's not just, that we get this bigger and bigger SI that comes up, but that you can then just reference to the data. So I hope that answered the question. I have a question. Could you please say what the AI toolkit and what we could do with that in NOMAD? Yeah, so I must say that I'm not, this is not my part of NOMAD, so to say. But the AI toolkit is a way where we have, like I said, with these Jupyter notebooks that we run, we have provided some schemas behind these, some ways to standardize a little bit what you do with this AI analysis, and we provide some notebooks with some examples of how you can query NOMAD and how you can apply this. And I believe there's more information on the website, but unfortunately I have to refer that. If you have more questions about it, I would really suggest that you could either email NOMAD email FAIRmat, and then we can put you in touch with the experts on this field, or you can have a look in our Discord, and then someone will be able to answer some more questions there. Can you integrate with other ELNs such as RSpace? So I'm not familiar with RSpace actually, but there is integration with other ELNs. The tricky part here is that there is not really a agreed upon data transfer between ELN. So there is the ELN file format, which we support reading. And we also support this mapping, right? So I talked about this JSON mapper, where if the ELN in question has an API, where they have some JSON schema of what it is that you get out from this API, then you can create mappings from this API so that you can say that, these fields should be mapped to these things in NOMAD. So we definitely, our goal is to try to support ELNs. We built an ELN in NOMAD because we felt the need for having a structured ELN. But fundamentally, we just want people to share their data in a nice way that it's reproducible. So we are very happy to try to read. So for example, we support ELAB FTW, we have integrations for lab folder as well, which are some of these ELNs. So by use case, where we have had users who want to have it, then we try to help them to set up this integration. So that should definitely be possible. I'll have a look our space after the talk is done. Do you support linking data to publications? For instance, adding a link to a paper once the paper is accepted. So you can publish with an embargo period, and then you could reference that. There's no, as far as I know, there's no automation that basically go and fetches and checks as soon as the paper is published, make this public as well. For now, it would still be that you would have to go back to your upload and click it as published or visible once the paper is published. That's maybe something we could think about. But it's definitely possible to you can publish it, put an embargo period on it. You could put the reviewers of your paper, if they really want to have a look at it, you can add those as reviewers to your data set before it's public. And then these reviewers can go and have a look at the data set whilst they're reviewing your paper. And then once the paper is published, then you could set the whole upload to being published. I've worked in groups at the edges of NOMAD since it started. However, my work is not in materials as such. I use the same DFT codes but work in biomolecular systems. Can NOMAD accept molecular data? Perhaps more to the point, does NOMAD actually want molecular data? Yes, we do. So one of the use cases that we have now, so NOMAD is quite old, right? It's from 2013 where we started with computational data, and there was very classical DFT, right? And now, as part of this FAIRmat, where we're trying to extend it to computations, to experiments, to synthesis and so on, and to measurements, we also try to extend the computational part. So we have one expert who is working on exactly this, to try to include biomolecular data, and are working on simulation parser for this. None of this is on the central NOMAD yet, as far as I know, but these are as part of these plugins that you can use. So I would highly advise you to reach out to us either through the email or through the Discord and so on. And then I think we should be able to find something how we can use this. Maybe there is something already implemented, or we could see how we could implement this. So NOMAD is very flexible. We accept all kind of data. We don't say that we don't want this data, right? You can write schemas for a lot of different things. Our focus is, of course, in solid state physics, but in principle, it's very flexible. As a repository, as an ELN, it starts to become like, if you start to work a lot with chemicals and so on, then maybe something like Chemotion is a better choice for an ELN, but NOMAD is still available as an archive that you can then upload these things in. I'm working on configuring a NOMAD Oasis for an NMR research community in the UK. Cool. I get asked often about NOMAD's financial backing and concerns about the supporting ending in the future if the funding finishes. Could you please offer some perspective into this and the support for collaborators using Oasis down the line? Now, that's an excellent question. I think, unfortunately, something that we deal with a lot in publicly funded projects. So what I can say is that we still have funding for 2 + 2 years at least. We are writing the next sort of proposal, so hopefully we will be funded for longer than that within the NFDI framework. And that being said, NOMAD has been around since 2013, right? Long before we got this funding that we have here, so we had been on different funding. And at this point within the classical DFT simulation, we're so big that it would be very strange if we didn't get funding to at least run the core functionality, right? We might not be at the level we are now with 30 centralized co-workers in the worst case, where we can develop a lot of new code, but for maintaining NOMAD security patches and things like this, I would see that it's quite hard that we would disappear, so to say. That being said, everything is open source, right? So there's nothing behind a paywall that you then don't get access to, right? So all of the code is published, and once you have your NOMAD Oasis running, the only thing in the standard configuration that you depend on NOMAD is this key cloak, right? Which you could then replace with your home key cloak if you wanted to, and then you are running as you want locally. Of course, then you have to manage the updates and so on. But like I said, I wouldn't be too worried about this. Of course, I understand, but the sad truth is that we cannot really guarantee anything when it comes to public funding, right? Because it's all dependent on whatever politicians is in office at the moment. The last thing I want to say there is that I think no tool is guaranteed to live forever, right? I think the main thing that I would at least look at if I look at these tools is how easy is it to try to understand and export the data afterwards. And I think NOMAD is nice in that it stores all of the raw files and all of the process files in a folder structure on your server. So really, if everything goes down and you cannot find anything, then all of the raw files, everything data, everything is there, so that you can ingest that in whatever tool is the next thing that we then try to work on. As an alternative to Zenodo in Vimeo, how easy is it to create a new deposit or to create a deposit using the same metadata already used for a collection of data sets? For instance, if they all have the same authors, creators. So at the moment, this is a little bit trickier in Nomad than in Zenodo, unfortunately. So we are working on a new graphical user interface where we will have a little bit more support for these user groups and so on. On your Oasis, you can do this, right? So there you can set up user groups so that you can say, you know, when I upload this, then I'm sharing this with my whole lab as co-authors, or I'm sharing this with my whole institute as reviewers, or even I publish this open so that everyone can see it. So there are views that you can do this, but unfortunately, it's not quite as built out as Zenodo is in that thing. But it is something that we are, you know, we are aware of these things and things that we are trying to work on. No? Does FAIRmat have industry members, e.g. working on solar cell? How secure is your system for them? Or are FAIRmat members all academics? So we are working together with industries on these solar cell things. It's so secret that I'm not sure if they are using it or not. No, but I think that there are some, at least in industrial collaborations where NOMAD is being used. The point is that once you're on your NOMAD Oasis, then it's running on your servers behind your firewall, and so it's up to your IT security how secure it is, right? So it's very configurable. On the central NOMAD, I'm not sure if any company would dare to put their proprietary data on this, and I mean, because I don't think anyone would do that. They don't have control over it. I don't think they're allowed from security perspectives, right? But once it's public, then they could push it there, right? But on the Oasis level, you know, it's really a closed system of databases running on your servers behind your firewall. So there's nothing from NOMAD's side going and doing anything in there. So you should be able to use this also for. We had some, actually, now this user meeting, the latest user meeting, we had some interested companies coming actually and asking how they could set it up, because a lot of the stuff that's powerful about NOMAD is this Dockerized container with all of these things already set up that you can just run directly without having to configure it too much.
Questions.
Yeah.
So thank you very much for everybody for your questions, and thank you especially to Hampus for the presentation and for answering all those questions. We actually, our webinar series is going to continue, so we actually have our next webinar scheduled for next week. So if anybody's interested in finding out more about some specific ELN projects, there's an event, there's a webinar about the Knowledger ELN system that will be presented next week, and you can sign up for that on our website. And also you can just find out more information about what events we are running through our website. You can also find us on all of the social media platforms, pretty much all of the major ones, and follow our YouTube channel where this webinar will go up, and there are previous recordings of various webinars. And if you're interested in finding out more about kind of things that go on when we announce them, we do have a JISC mail mailing list, and you can find that in our website footer at the moment. So I think all that really remains to be said is to, if my slide is going to, yes, if my slide is going to go, just to say a massive thank you to you all for joining us today, and a massive thank you to Hampus for joining us to present the webinar. And I look forward to, you know, everybody finding out a little bit more about NOMAD by going through to the links. We will be sending out an email shortly after this webinar, just including the link to the slides and some of the links that are of interest. So thank you all very much. I hope you have a wonderful rest of your day.